This video at National 5 is all to do with indices, everything you need to know about indices. You've got quite a few rules. You learned in class that you have about, I don't know, about 6 rules maybe in total that will cover every type of question that you can get at National 5. Now this type of problems at National 5, they're pretty straightforward, usually worth about 3 marks in total. So let's look at the things you have to know about. Well, here's some rules. A to the power m times a to the power n. Well, that's the same as adding the powers. Okay, we'll add the powers here. So a is called the base number, and the power is called the index number. So base number is a, and the index number is m. In this case, base number is a, and the power is the index number. Now, for this rule to work, you have to have the same base number. It only works with the same base number. So that's the first thing to notice. Okay. Next rule is a to the power m divided by a to the n. And again, in class you should have learned that that is a, and we subtract the power, so that's m minus n. Okay. Next rule, a to the power 0. A to the power 0, n to the power 0 is 1. Okay, comes up time and time again. And if you don't believe me, pick a number for a, put it to the power 0, press equals, and you get the value of 1. Next rule is a to the minus m. Now if you have a negative power, then that means that you're going to have a fraction, and it's 1 over a to the m. And that's quite easy to prove. I'm not going to prove it here, but it's quite easy to prove that. Okay. So that's the next rule you have to know. Next one's power of a power. A to the power m all to the power n is equal to a to the power m times n. So that's us multiplying the powers. It's called power of a power. I like to call it the power of a power. And the last rule, if we've got a fraction, so if we have a to the power m over n, that's a fractional power, well, that's the same as the nth root of a, all to the power m. Another way we could write that is we can write the nth root of a to the power m. These two things are the same, but in reality, when we're working with it at National 5, this is the one that we use a lot of. Okay, so this one's not very useful. It's normally that one that we use. So there's all the powers, or sorry, the rules that you have to know. So let's apply them to questions at National 5. So the first one to do, we'll start off nice and simple, and what 2a times a to the power minus 4. Okay, or negative 4. Now the wee dot I put up in my rules there, that means times. Okay, we don't tend to put a times in, although I put a times here. The wee dot represents a times in mathematics when you get onto the higher levels, because the times symbol looks like an X and it can cause confusion. So how do we work this out then? Well, that a, 2a there, that a is actually the power 1 that you never write in, but you've got to know that that's a to the power 1. And now it's quite simple for us to work out the value of this. So this is how it goes about. This is 1, a to the power negative 4. So we deal with the normal numbers first. So 2 times 1 is 2, and it's a to the power, using this rule, we add the powers, that's to 1 add -4 is -3. And you could write that as 2 all over a to the power 3, using this rule here. Okay. Do you have to do that? Well, it's good practice to do that. I would always do that in the exam just to be on the safe side. Okay. Sometimes in an exam they'll ask you to do that and leave your power as a positive power, which means you have to do that bit there. Okay, let's look at the next bit, or the next question. Along the same lines, using some of the same formulas, but introducing another one as well. Y to the power 8 times bracket y to the power 3 all to the -2. So, remember your order of operation. You have to do the brackets first. So I have to do this one first. So let's deal with that first a minute. But how do we do that? Well, look at the rules. Should find out that that's that rule there. That's called a power of a power. We've got a power to another power. The rule tells me that I multiply the two numbers together. So that's y to the power 8 times y to the power -6. 3 times -2 is -6. And now we apply the rule up here. We're multiplying. Multiply, same base number, we add the powers. So adding the powers there, that's y to the power 2. 8 plus -6 is 2. And that's one answer. Right, the next one I'm going to do is, it's going to involve just numbers, so we're not going to have any algebra in it, it's just going to be a number to a particular power. So we have 8 to the power 2/3. So how do we work that out? Well, that's going to be this rule here. Look at that rule there. That's a number to a fractional power, and we're going to use this part here. So that's going to change to the cube root of 8 all to the power 2. Now what does the cube root mean? Well, I'm just going to put a wee bit over here just to show you. Cube root of 8, that means some number, so we'll just call it a, some number times itself 3 times must give me the value of 8. So if we start at 1, 1 times 1 times 1, well, that's just give me 1, and go to 2, 2 times 2 is 4, times another 2 is 8. So the cube root of 8, well, because 2 times 2 times 2 equals 8, the cube root of 8 is 2, and that's all to the power 2, so our answer to that is 4. Okay, so that was us using the last rule there, down here. Okay, all these questions are quite simple. If you know your rules and you've practiced them, then these questions are quite simple at National 5. Let's look at this one. 2 to the power 0 plus 3 to the power -1. Well, let's look at the rules again. 2 to the power 0, well, that's that rule there. A to the power 0 is equal to 1. A being any value. So anything to the power 0 is 1, so we've got an answer to that. Plus, well, 3 to the -1, well, that's that rule here. So that gives me 1 over 3 to the power 1, but we never put the 1 in, so that's just 1 over 3, that's a third. We'll just take that 1 out, because you'll never see that in any textbooks. We don't put the power 1 in. So we can just tidy that up, 1 plus a third, well, that's 1 and a third. And we could write that top heavy, that's the same as 4 over 3, whichever way you would like to write it there. Again, nice and simple. So let's look at another one. Let's look at ones with brackets in it. Brackets are quite common to come up. So So m to the power of half, bracket 2 plus m to the power 2. Well, we could do the grid method for that, and I think I will do the grid method because in our school we use a grid method. So we have m to the power of half, we have 2 plus m to the power 2. So 2 times that, well, that's 2 times that, so we have 2 of these. So that's 2 of the m's to the half. Lots of people make a mistake there and put m, that wouldn't be true. We have 2 of these. And the second part, it's that times that. So that's the first rule there. So we add the powers. 2 plus a half, well that's 2.5. And that's the same as 5 over 2. Again, a common mistake there. People multiply the powers. You don't multiply the powers. The rule tells us we add the powers. So my final answer is 2m to the half plus m to the power 5 over 2. Okay. Let's look at another question, see if we can find ones that are... Yeah, here's another one that very similar to the last one. A to the power of half, a to the power of half again, minus 2. So, grid. A to the half, a to the half, minus 2, and we have to multiply them out. So a to the half times a to the half, well, back to rule 1 again, we add the powers. A half plus a half is 1, so that gives me a value of just a to the power 1, which is just a. And again, a to the half times 2, that's going to be minus 2a to the half. So my final answer is a minus 2a to the half. Find any other questions that are reasonable? Yeah, well, here's one here that, again, you have to know your basics here. This question here, very simple question, but you'll be amazed at the amount of people who can't do this type of question or don't know how to do this. Now, if you don't know how to do that, it means you've not learned your rules on this side here. You need to know all these rules. Now, if you know these rules, as I say, these questions are very simple. So, m to the power 3 times m, well, the root there, we have to get rid of that root. Well, you have to know that the square root means power 2. So, square root is a power a half. Okay, so there should be a 2 up here, but that's actually m to the power 1. So overall, the power is a half. Okay, let me just explain this a wee bit better. When you have the square root, we have a 2 here that you never see. The normal square root sign is just that, but there should be a 2 there. And we have an m in here, and an m, again, we don't see the power here, but the power is 1. So using this rule here, okay, the root power is the bottom of the fraction, and the m power is the top of the fraction, so it's m to the half. Okay, so we multiply the m's together, means we add the powers, that's that rule. So that's m to the 3.5. 3.5 is the same as 7 over 2 as a top heavy fraction, and that's your final answer. Okay, again, lots of people would write there 3 times a half is 3 over 2. We don't times the power, we add the powers. A dead easy mistake to make. And maybe just remind you here, I would, in the back of your mind, have the square root is the same as, whatever you've got to the power of half. I think that's well worth remembering. So if you're taking wee notes in this video, make sure you know that. But again, if you've done plenty of these, you will know that off by heart. Okay, so that was a simple wee question, but if you don't practice these, you would never get the answer to that one, even though it's quite straightforward. Right, here's another one with a bracket in it, x to the half. See how we make indices a wee bit harder by, rather than just giving you integer powers, we give you fractional powers, and that adds a wee complication to it. So, what do we do there then? Well, we set up our grid. So with x to the half, 3x plus x to the minus 2. Well, it's that times that. So remember, the power is 1 when you don't see it. We're multiplying here, so we add the powers. So that's 1x, so 1 times 3 is 3. And it's x to the power. We add the powers. So it's 1 plus a half, which is 1.5, which is 3 over 2. Plus, we're multiplying here again, so we add the powers. So adding the powers here, then it's a half plus negative 2. Well, you should know that that's negative 3 over 2. So our final answer here is 3 x to the 3 over 2 plus x to the minus 3 over 2. And you can't tidy these because the powers are different. That's a negative power, that's a positive. So don't think you can tidy these up. Don't think you can add these to get 0 because you're not multiplying, that's an addition sum. Okay, so lots of wee areas to trip you up if you haven't practiced this. Okay, right, that's all the questions I've got at National 5. That's old National 5 and credit questions there. See if we can find some more for you. I think we'll practice another few. I think there's another couple that might be quite interesting. Yeah, let's go back to a number type question. 16 to the power 3/4. So that's back to the bottom rule here. So we can write that as the bottom part of the fraction is the root. So that's the 4th root of 16 all to the power 3. So remember what the 4th root is of 16. Well, that's going to be a times a times a times a, and all that must be equal to 16. So what number times itself 4 times gives me 16? Well, you just think about it, it should be 2. 2 times 2 is 4, times another 2 is 8, times another 2 is 16. So this part here, which is a bit in the bracket, has an answer of 2, and it's all to the power 3, which gives me an answer of 8. So we have 8 as the final answer. You can put that into your calculator and you can check that answer to make sure you're right. In your exam you won't have a calculator, this will be paper 1. We expect you to be able to work with the numbers. We'll do any more. Yeah, let's go for one like this. 3a to the power 5 times 2a all over a squared. Well, you break this question down. Let's deal with the top bit of the fraction first. Well, the top bit of the fraction is the top rail. Remember, if you've got 2a, that a is the power 1 that you don't see. So we deal with the normal numbers first. 3 times 2 is 6. And it's a to the power. We add the powers. That would be to the power 6. All over a to the 2. Well, we can tidy that up. 6 divided by 1, this is 1a squared, so there's a 1 there that you don't see. 6 divided by 1 is 6. And we use the second rule here. We're dividing, and it's the same base number, so we subtract the powers. So that's going to be a to the power 4. Final answer. Quite a common question, that one. Let's look at one that just involves fractions that can throw a lot of people. A to the power 2/3, bracket a to the 2/3, minus a to the minus 2/3. So we have the same index number, same power, but one of them's negative here, but the same numbers, it's 2/3 everywhere. So, grid. A to the power 2/3, a to the power 2/3, minus a to the minus 2/3. Well, first bit, we multiply together, so we add the powers. 2/3 plus another 2/3. Well, that means we have 4/3. So that's 4/3. Minus a to the power 2/3 times a to the minus 2/3. Well, we add the powers again. So 2/3 plus negative 2/3. That gives me 0. So that's a to the power 0. So what you have to do there is a to the 4/3 minus a to the 0. But remember that rule, n to the power 0 is 1. So your final answer is a to the 4/3 minus 1. Lots of people miss that mark in the exam going from here to here. You must, if you got n to the power 0, you must write it as 1. Okay. Do one more, I think, and that's us. That's all the different types you get at National 5 level. You can see that there's very few different types. Another thing I would say to you is it's all quite simple if you practice it. If you don't practice it, it's dead easy to make a mistake as well. So a wee bit of hard work, a half an hour of work, and everything will be sorted. Learn your rules. So again, your grid. P to the power 3, p to the power 2 minus p to the minus 3. Now what I would say there is this question is a wee bit easier because our powers are all integers with no any fractions, so this is a wee bit easier. So multiplying p to the power 3 times p to the power 2, we add the powers, so that's 5. Don't be tempted to write 6 because that'd be wrong. Minus p to the power 3 times p to the power minus 3, you add the powers, that's p to the 0 again. So that's p to the 5 minus p to the 0. And again, this rule here equals p to the 5 minus 1. Okay, I think that's all the questions that I can do, all the different types that I've saw. So I think we came across every type for that, so no point in me doing, well, maybe do one more. We didn't do lots of division, so let's do another division one just before we finish. What about this question? 6x to the power 3 over 2 divided by 2x to the power a half. Well, I would like to write that as a fraction. So that's 6x to the power 3 over 2 all over 2x to the half. I think that's a better way to do it. That's the way we've got here. So it's this rule here. So deal with the numbers, the normal numbers first. 6 divided by 2 is 3. And it's x to the power. Well, we subtract the powers. 3 over 2 minus a half. Well, that's 3 halves, take away a half, so that's 2 halves. 2 over 2 is 1. That's our answer. Because that's the power of 1. 3 over 2, take away a half, is 2 over 2. 2 over 2 is 1. So we would just write that as 3x. Okay, so that's Indices done for you at National 5 level. Do the rules, make sure you know the rules, and practice the different styles. Any more practice you want, mathswithrevision.com, National 5, look under surds and indices, and you'll find plenty of practice in there.